Hello students, how are you all? I hope that you all are good. As we know, the series of motion in a plane is going on and we have successfully finished the 13 lectures, right? So in a previous lecture that we have discussed about position, displacement, velocity and acceleration is in the form of vectors and we have find their magnitude and their direction from positive x-axis. So at the end of the session we are solved some example problems, right? So in today's lecture that we are going to discuss about an important concept that is relative velocity. Okay, so what is the meaning of relative velocity? What is the formula for relative velocity when the objects are moving in a same direction or when the two objects are moving in an opposite direction and when the two objects are moving in a perpendicular direction and their formulas that we are going to discuss in today's lecture, as well as at the end of the session we are going to solve some example problems, right? Are you ready? Shall we start the session? Okay, so my name is Rakesh. Welcome to our beautiful physics channel, Rakesh sir Physics. Shall we start the session? Okay, so what is the chapter going on? So the chapter is motion in a plane. Motion in a plane. Okay, and this is the class number 14. Class number 14. And what is today's concept? Today's concept is what, ma? Relative velocity. Relative velocity. So, in general, relative velocity means, have a look, the velocity of an object, the velocity of an object with respect to and another object with a common frame, okay. So what is the meaning of the relative velocity? The velocity of an object, with respect to an another object, with common frame, where common frame is nothing but ground frame. Common frame is nothing but what, ma? Ground frame or earth frame or an observer. Okay, so whatever it is. So the velocity of an object with respect to another object with a common frame. What is the meaning of common frame? Either ground frame, earth frame, whatever it is, observer. Okay, so have a look. I'm going to draw the diagram. So let us consider this is a S frame. What is this? S frame, and it is a common frame. This is what, no? This is a common frame. Common frame is nothing but what? Ground frame or observer or earth frame, whatever it is, it must be at a rest position. That frame must be at a rest position. Are you getting? Right? Right. So according to definition, the velocity of an object with respect to another object with common frame. So we have taken the common frame. Now what we need? We need the velocity of an object with respect to another object. That means now we require two objects, right? So with respect to this S frame, with respect to this common frame, and we need two objects. Here I am taking, there is a particle P is in motion. There is a particle P is in motion with respect to S frame. Okay, right. I am taking one more frame. S dash. S dash frame is also nothing but an object. So now these two are the objects which are in motion with respect to S frame. With respect to S frame, particle P and S dash are in motion. Okay, right. Now at any particular instant of time, T, and just take the photograph and the observer and the S frame. So with respect to me, so particle P and S dash are in moving. I wanted to find their velocities, relative velocity at a given time. Now what I have to do? I wanted to analyze their situation. For that, just take the photograph at that particular instant of time. So this is the position of point P and this is the position of S dash frame. Okay. Now with respect to me, I wanted to find the positions of particle P and the S dash frame. Okay. So further, how to find the position in our yesterday's lecture? I told you that just we have to draw the straight line from the origin. So what is this straight line shows? This straight line shows the position of R means what, ma? R is the vector which denotes the position of a given point in the plane. So the position vector of point P with respect to S prime. RPS means what, ma? So R bar PS means the position of the position of point P, the position of point P with respect to S, with respect to S. Okay, right. Now, at this particular instant of time, position of this S dash frame with respect to S frame. Position of R is nothing but position of S dash frame with respect to S frame. So, R S dash S means what, ma? The position of S dash frame, the position of S dash frame with respect to S frame, with respect to S frame is given by R S dash S. Now, if I wanted to find the position of this particle P, position of this particle P with respect to S frame, with respect to S frame is given by, so this line gives what? The position of particle P with respect to, this line is drawn from the origin of S dash frame. Now this line gives the position of particle P with respect to S dash frame, with respect to S dash frame. Now what is RP S dash? The position of particle P, the position of particle P with respect to S dash frame. Are you getting any doubts? Okay. Now I'm going to analyze the diagram. Have a look. From this diagram, this diagram is like this. What is this? Position of the particle with respect to S frame. Position of the S dash frame with respect to S frame. This is the position of particle P with respect to S dash frame. Already we have discussed about a vector addition in triangles law. Okay now. So in parallelogram law, what I told you that, have a look, R S dash S and RP S dash. So these two vectors are in order. Have a look, these two vectors in order. Now RPS, this vector is in reverse order. Now the sum of these two. So R S dash S plus R P S dash. So these two vectors are in order. Then their sum is given by, so the third vector which is in reverse order. Are you getting any doubt? Now I'm just going to differentiate the above equation. Differentiate above equation with respect to time. I'm just going to differentiate the above equation with respect to time. Have a look. So d by dt of R S dash S plus d by dt of RP S dash is equals to d by dt of RPS. Are you getting? Okay. So the differentiation of position vector, the differentiation of d by dt of position vector or displacement gives what, ma? Velocity. So R S dash S means the velocity of S dash frame, with respect to S frame. The velocity of S dash frame with respect to S frame. So what is V S dash S? Velocity of S dash frame with respect to S frame. S frame. S is nothing but what makes a ground frame, observing frame, F frame, whatever it is. So plus d by dt of RPS. It gives velocity of particle P with respect to S dash frame. So what is V P S dash? The velocity of particle P with respect to S dash frame. That is equals to d by dt of RPS. That means velocity of particle P with respect to S frame. Are you getting? What is VPS? VPS means the velocity of particle P with respect to S frame. So this is about a relative velocity. From the general definition of relative velocity, so what is the meaning of relative velocity? The velocity of an object, with respect to another object, with common frame, Now what we have to find? We have to find velocity of an object with respect to another object. Is gives what, ma? Relative velocity. So we have to find VP S dash. So where is VP S dash? Here VP S dash is there. So velocity of particle P with respect to S dash frame, with respect to S dash frame. So Vp S dash is equals to Vp S dash is equals to Vps minus, if this term went to that side, it become S dash. So this equation shows the relative velocity of P, particle P with respect to S dash frame, with respect to S dash frame. So now what is this? Velocity of particle P with respect to S dash frame. The velocity of an object with respect to another object with common frame. Have a look. Vp S dash is equals to, we got Vp minus Vs dash. Vp minus Vs dash. Have a look. Here S is there. Here S is there. S represents what? Common frame. Velocity of first object minus velocity of second object with respect to common frame S. Yes, S, common frame S. So this is the concept of relative velocity. I hope that you are understood. Okay, just pause the video and write the notes. Pause the video and write the notes. Any problem? Any difficulty is there? No difficulty is there, na? Okay, very good. So just pause the video and write the notes. 3, 2, 1, go. Right. So we got the equation for relative velocity of particle P with respect to S dash frame. The velocity of particle P with respect to S dash frame, that is equals to what, ma? Velocity of particle P minus velocity of frame S dash. Velocity of frame S dash. Have a look. Vp S dash is equals to Vp minus Vs dash. So this gives the relative velocity of particle P with respect to S dash frame with a common frame. What is the common frame here? S is the common frame. S is nothing but ground frame, earth frame, whatever it is. So S is nothing but what, ma? It's a ground frame. It's a ground frame. Now this formula becomes Vps dash is equals to Vpg minus Vs dash g. S is nothing but it's a ground frame. Okay, so that's why I'm taking capital G at the place of S. Are you getting any doubts? Right. From this formula, so I'm just going to write the formula like this. So what is this? This is a ground frame, S frame, common frame, whatever it is. So here is a particle P is there. Okay, and this is what? S dash frame. Now I wanted to find the velocity of this particle P. Velocity of this particle P with respect to ground frame. Velocity of particle P with respect to ground frame. Have a look. From this equation we can write velocity of particle P with respect to ground frame. With respect to ground frame is equals to, we can write of particle P with respect to S dash frame plus, if minus term comes to this side, it becomes velocity of S dash frame with respect to ground. Are you getting any doubts? Okay. If you wanted to find the velocity of S dash frame with respect to ground, velocity of S dash frame with respect to ground, have a look. Velocity of S dash frame with respect to ground. Velocity of S dash frame with respect to ground. If this term comes to this side, it becomes plus. So here we have velocity of particle with respect to ground, and if this term comes to this side, it becomes minus velocity of particle P with respect to S dash frame. Okay, so these are the formulas of this particle P and S dash frame with respect to ground. Are you getting any doubts? Right. So let us consider, this is our equation number A, capital A. Okay, so what is capital A? We have equation capital A. What is that? Vp S dash is equals to Vp G minus V S dash G. V S dash G with respect to ground frame, with respect to ground frame. Just differentiate above equation with respect to time, with respect to time. So then we will get, have a look, d by dt of Vp S dash, that is equals to d by dt of Vpg minus d by dt of Vs dash g. Differentiation of velocity d by dt of v gives what, ma? Acceleration. So this gives acceleration of particle P with respect to S dash frame, that is equals to acceleration of particle P with respect to ground frame minus of x dash frame with respect to ground. So this gives what ma? So this gives the relative acceleration of this particle P with respect to s dash to AP minus AS dash, but with respect to ground frame. Are you getting any doubts? Okay. So these are the formulas. Right. Have a look. So note number one. Note number one. Okay. So if the two objects, if the two objects capital A and B, capital A and B are moving with a speeds, with a speeds or velocities, whatever it is, with a velocities VA and VB, VA and VB in same direction, in same direction. Then the relative velocity of object A with respect to B, object A with respect to B is given by the relative velocity of an object A with respect to B. In a simple way, I will explain. Have a look. So this is a ground frame. Let us consider this is a ground frame and it is a rest frame. Okay. So on this rest frame or on this ground, there is a two objects. Let us say this is a first object and this is a second object A, B. Okay. So on the surface of the ground, these two objects are moving. So this is the velocity of an object A, let us say VA, and this is the velocity of an object B, let us say VB. What we are finding? We are finding relative velocity. So simply relative velocity of an object A with respect to an object B. Velocity of an object A with respect to an object B means the difference between the velocities of an object A and the object B. Difference means what? Difference gives by negative sign. Difference gives by negative sign. Have a look. So relative velocity of an object A with respect to B means simply the velocity difference between an object A and difference can be denoted by negative sign and B. So relative velocity means what? The difference between the velocities of given two objects. Here object A and object B. So VA minus VB. This is a relative velocity. Okay, is it clear? Any doubts? Right. So from this condition, have a look. VPS dash. VPS dash means the difference between velocity of particle P and velocity of particle S dash or frame S dash. VP minus VS dash. Sir, why we are taken here ground? Why we are taken ground? Ground is nothing but common frame. Why we are taken S or G here? Why we are taken GS here? So why we have to take G and G here? Have a look. So what is this? This is a ground frame. This is a ground frame and rest frame. This is a rest frame. So whenever the two objects, what is this? An object A and this is an object B. Now this object A is moving on the surface of the ground. Moving on the surface of the ground. This object B is also moving on the surface of the ground. Also moving on the surface of the ground. So who is the first observer? Who is the first observer with respect to these two objects? Who is the first observer with respect to these two objects? So ground. So this ground sees the two objects. It is observing the two objects. So with which much velocity this object is moving? With which much of velocity this object is moving? So that's why I am considering the velocity of an object A as velocity of an object A with respect to ground. So what is the velocity of ground? 0. It is a rest frame and it is observing the two objects with which much of velocity they are moving. Are you getting? So that's why here we have to take G and G. Why we have to take the G? So G means the velocity of the two objects with respect to ground frame, because these two objects are moving on the surface of the ground, Who is the first observer for these two objects? Ground is the first observer. Are you getting? Any doubts? Right. So this is a concept, I don't know whether you are understood or not. So please comment either if you are understand or not understand. So VA minus VB is what? Velocity of A minus velocity of B with respect to ground. with respect to ground, and these two objects are must moving with a velocities Va and Vb in same direction. So this is the velocity, relative velocity of an object A with respect to B when these two objects are moving in a same direction. That means, so this is a first car. It is moving with velocity Va, and this is a second car, and this second car is also moving with velocity Vb in same direction. In same direction. Then the relative velocity between these two objects is given by Va minus Vb with respect to ground. These two objects are moving on the surface of the ground. Okay, right. Note number 2. If the two objects, if the two objects are moving in are moving in opposite directions, moving in opposite directions. That means, so at this time, the velocity of an object Va is in this direction, and the velocity of an object B, is in this direction. Now we have to find out the relative velocity of an object A with respect to B. Velocity of an object A with respect to B. In general. So we can write the difference between velocity of A minus velocity of B. Have a look. With respect to this object A, this object B is moving in opposite direction. Where negative sign shows, VB is opposite to Va. So negative sign shows what mark? So the velocity of an object B, which is opposite to the velocity of an object A. So then we can write VAB is equals to VA plus VB. So this is the formula when the two objects are moving in opposite directions. So what is this? Relative velocity between two objects when they are moving in opposite directions. Note number 3. If the velocities of the object, objects are perpendicular to each other, or what ma? Perpendicular to each other. Okay, so have a look. So let us consider this is the velocity of an object A, and this is the velocity of an object B. At this time, the two velocities of the objects are perpendicular to each other. The velocity, relative velocity of an object A with respect to an object B in the form of vectors, is given by under root of VA square plus VB square plus 2VA VB cos theta. In the form of vectors I am finding now according to parallelogram law of vectors. What is theta here? Theta is equals to 90 degrees. Then the value of cos 90 becomes 0. So this term becomes 0. Then the relative velocity of an object A with respect to B is equals to under root of VA square plus VB square. Plus VB square. What is velocity? Velocity is a vector quantity mark. So that means vector means it has both magnitude as well as direction. We must consider its direction also. Whenever the object is moving from the origin towards this direction, what is this? Positive x, negative x, positive y, negative y. If the object is moving in this direction with respect to positive x direction, what is the unit vector? The object's direction is given by I cap. If the object is moving in this direction, then direction of that object is given by the unit vector minus I cap. If any object is moving in upward direction, its direction is given by the unit vector j cap, and if it is moves in this direction, and its direction is given by the unit vector minus j cap. So I cap minus I cap, j cap minus j cap. Are you getting any doubts? Why I am taking the direction? Because velocity is a vector quantity. It has both direction as well as magnitude. So what is this? This is the resultant relative velocity when the two objects are moving perpendicular to each other. Now if you wanted to find its direction, so what is its direction? So direction can be given by the trigonometrical function tan theta. What is tan theta? The component of y divided by component of x. So what is the component of y? Here we have the component of y is what ma? VB divided by what is component of x? VA. So this gives the direction of the resultant relative velocity of an object A with respect to B. Are you getting any doubts? Oh. So just pause the video and write this part. Pause the video and write this part. 3, 2, 1, go. Right. So let us see. Note number 4. Note number 4. Right. In general, what is the meaning of relative velocity? So VAB is nothing but velocity of an object A minus velocity of an object B. So with respect to ground frame, with respect to ground frame. So VAB magnitude is equals to magnitude of VAG minus VBG. Okay, so this is a magnitude. So observe this term. What is this term? This term shows the subtraction of the two vectors. This term shows the subtraction of the two vectors. So what is the formula for subtraction of two vectors? So magnitude of VAB bar is equals to under root of VAG square plus VBG square minus 2 VAG VBG cos theta. Cos theta. Are you getting now? Subtraction of two vectors. Okay. Right. If you wanted to find its direction, now if you wanted to find its direction, what is its direction? Let us consider. Let us consider this VAG vector. Have a look. This is VA. This is VB. The angle between these two is, let us say, an angle theta. Okay, what we are doing, we are subtracting VA minus VB, VA minus VB. So just take the negative vector, that is minus VB. So all these things we are discussing in a subtraction of two vectors. So now what is this angle? 180 minus theta. So what is this velocity of an object A with respect to ground? With respect to ground. Now what is the resultant? So this vector gives the resultant of these two vectors minus VBG. So now this resultant vector is making an angle alpha with the VA vector. Now what is the direction of R bar vector? That is equals to tan alpha is equals to B bar, that means VB bar sin theta divided by VA minus VB cos theta. So this equation gives what now? This equation gives the direction of the resultant vector of these two velocity vectors. Are you getting? So subtraction of vectors, this is A, B. Then the direction of subtraction of two vectors is given by B bar sin theta by A bar minus B bar cos theta. So here at the place of A and B we have VA and VB. That's it. Okay. Any doubt? Right. If you want to find the acceleration, relative acceleration. Okay. So there is a two objects. Let us say this is the first object A. So the acceleration of this object A is A. So the acceleration of the second object, let us say this is B, and its acceleration is A B. With respect to these two objects are moving on the surface of the ground, then A AG, A BG. Okay. Now acceleration of an object A with respect to B is given by acceleration of A minus acceleration of B with respect to ground frame. Okay, same thing, whatever we are did here, just do it for acceleration. Okay, so if the two accelerations are in opposite directions, so object A acceleration is in this direction, and the direction of an object B's acceleration is in this direction. Now the resultant relative acceleration of an object A with respect to B is given by AA minus AB. So minus into minus plus AA plus AB. So with respect to ground. Okay. So when these two accelerations are moving perpendicular to each other, then the resultant relative acceleration is given by AB is equals to under root of A square plus A B square, and its direction AB divided by AA. Same thing, same sigma. Okay, but at the place of V you get A. That's it. So if you wanted to find the subtraction of these two accelerations, so this is the formula. To find the direction of subtraction of two vectors, you have to use this formula. But at the place of V, just you have to write A. You will get the same things. Okay now? Okay. Pause the video and write all the formulas. I hope that now you got the complete idea about relative acceleration and relative velocity, right? Right. Let's see solve some example problems. Okay. Pause the video and write the notes. 3, 2, 1, go. Right. So I'm just bring the two example problems. Have a look. What is the first problem? An object A is moving with a 5 meter per second and a B is moving with 20 meter per second in same direction. In same direction. Let us consider the direction of the object is a positive x direction. Positive x direction. Okay. So the two objects are there. The two objects are moving along the positive x direction with 5 meter per second and 20 meter per second speeds in the same direction. Find out the relative velocity of an object B with respect to A and the relative velocity of an object A with respect to B. So already we have discussed the formulas. So please just pause the video and try the solution. Okay. 3, 2, 1, go. I am going to solve the solution. Have a look. I told you that. So velocity is a vector quantity. It has both direction as well as magnitude. Have a look. So this is a positive x direction, negative x direction, y direction, minus y direction. This is I cap, minus I cap, j cap, and this is minus j cap. So the two objects are moving with a speed 5 meter per second and a 20 meter per second. Let us say this is an object A. Okay, so this object A is moving with a speed of 5 meter per second, and another object B is moving with 20 meter per second. So let us say the velocity of an object A, VA is equals to how much? 5 meter per second, and it is moving in which direction? Positive x direction. So what is the unit vector along positive x direction? I cap. So velocity of B is equals to velocity of an object B, that is VB. It is also moving in a positive x direction with a velocity 20 meter per second, and its unit vector is also I cap because both are moving along positive x direction. So what is the first question they are asking? Find the relative velocity of B with respect to A. So the relative velocity of an object B with respect to A, that is equals to, so we can write velocity of an object B minus velocity of an object A. Velocity of an object B minus velocity of an object A. This is a formula for relative velocity. So these two objects are moving on the surface of the ground. So G, G, B, A, G, B, B, G. So ground, ground. So that is equals to, what is the velocity of an object B with respect to ground? 20 I cap, minus what is the velocity of an object A with respect to ground? Minus 5 I cap. So 20 minus 5, 15 I cap. So the relative velocity of an object B with respect to A is equals to how much more? 15 I cap. Are you getting any doubts? Okay. So B. What is B? Relative velocity of an object A with respect to B. Relative velocity of an object A with respect to B. That is equals to VAG minus DBG. Okay. So that is equals to, what is VAG? So VAG is equals to 5 I cap minus VBG. VBG is equals to how much? 20 I cap. So 5 minus 20. 5 minus 20 is equals to how much, ma? Minus 15 I cap. So velocity of an object A with respect to B is equals to minus 15 I cap. Okay. So that means here velocity of an object B with respect to A is equals to, we got how much? 15 I cap. Here velocity of an object A with respect to B, we got minus 15 I cap. That means in this case, have a look. This is a velocity of an object A, 5 meter per second. So the velocity of an object B, 20 meter per second. Absolutely, the velocity of an object B is more than velocity of an object A. How much more it is? 15 I cap. 15 meter per second is more. So if you comes to this, the velocity of an object A is less than velocity of an object B. How much it less than? 15 meter per second less than. So here negative sign shows the velocity of an object A is behind the velocity of an object B. So here we got a plus. That means the velocity of an object B is ahead 15 meter per second velocity than velocity of an object A. Are you getting? Right. So let us come to second one, solution. So what they are given, have a look. Two objects capital A and capital B are moving each with velocities 10 meter per second. So they are given two objects. That two objects are moving with the same speed. What is that? 10 meter per second. A is moving towards east and B is moving towards north from the same point as shown. Okay. So they are taken two objects. Okay. So as shown, they are given one figure. So velocity of an object A velocity of an object b. So what are the velocities of the objects? They are having the same velocities, 10 meter per second, 10 meter per second. Okay, these are the velocities of objects. So from the point O, velocity of an object A is towards east direction, and the velocity of an object B is in north direction. They are given. Okay, north direction from the same point as shown in the figure. Find the velocity of an object A relative to B. What they are asking? They are asking to find the relative velocity of an object A with respect to B. Velocity of an object A with respect to B is equals to how much? Okay, so VAB we have to find. Just pause the video and find the velocity of an object A with respect to B. So pause the video and try the solution. 3, 2, 1, go. I'm going to solve the solution. Have a look. As we know that, so what is this? X minus x, y minus y, I cap minus I cap, j cap minus j cap. Okay, so these are the directions. This velocity of an object VA is moving towards east direction. Is moving towards east direction. This is east, west, north, south. So east direction, east direction. Then velocity of an object A is equals to how much more? 10 I cap. I cap is the direction of the given velocity of an object A towards east direction. So I cap is the unit vector along positive x direction. So velocity of an object B, it is moving towards north direction. What is the unit vector along north direction? J cap, 10 J cap. What they are asking? They are asking to find relative velocity of an object A with respect to B. So that is VA minus VB with respect to ground. With respect to ground. So these are the velocities of the two objects with respect to ground. So that is equals to velocity of A with respect to ground. How much? 10 I cap minus velocity of an object B with respect to ground. How much? 10 J cap. So velocity of an object A with respect to B is equals to, we got 10 I cap minus 10 J cap. So the relative velocity, the direction of relative velocity. Have a look. What is this? VA. What is this? VB. So have a look. From this condition, VA is equals to 10 I cap, VB is equals to minus 10 J cap. VB is equals to minus 10 J cap. So from this relative velocity condition, we can draw the diagram like this. Have a look. This is 10 I cap minus 10 J cap. So this is plus I cap. This is what? Minus J cap. Minus J cap. So have a look. Velocity of an object towards 10 I cap. So this is what? VA is equals to 10 I cap. So VB is equals to what? Minus 10 J cap. Minus 10 J cap. That means its direction towards the south. Its direction towards the south. So VB is equals to how much? 10 meter per second towards downward direction. Towards downwards. So now what we have to find the resultant relative velocity of VA and VB. So VA and VB. So what is that? So this is the resultant direction of relative velocity of A with respect to B. So how can we find? So just we have to take its magnitude. So that is equals to root over 10 square plus 10 square. How much more? Equals to root over 10 square, 100, 10 square, 100. So we got how much more? So VAB is equals to, we got root 200. So root 200 can be written as 2 into 100. So that is equals to 10 root 2 meter per second. So how much more? The resultant of these two vectors, is given by root 2 into 10 or 10 root 2 meter per second. Are you getting? So this is the resultant velocity of VA and VB. And in which direction it is moving? So this is what? East. This is what? South. So the resultant velocity direction is what? Southeast. What ma? Southeast direction. So the resultant of these two velocities is towards southeast direction. Okay. And if you wanted to find the resultant of this velocity vector, so how can you find? By using the formula of tan theta. So what is tan theta? Tan theta is equals to, so how can we take theta from positive x-axis towards the slope? From positive x-axis we have to take an angle theta. So tan theta can be written as opposite side by adjacent side, y component by x component. What is y component? 10. What is x component? 10. So 10 cancel out, you will get 1. So tan theta is equals to, we got 1. So 1 can be written as what ma? Theta is equals to tan over 45 degrees. Tan 45 degrees. So the tan 45 degrees value is how much? 1. So tan get cancelled out and theta is equals to, you will get 45 degrees. That means from the positive x-axis, this resultant velocity makes an angle 45 degrees. So if this is 45, then this is also 45 degrees. Are you getting any doubt? Just I am write the equation for relative velocity. So this is what resultant relative velocity of A and B objects. So 10 I cap minus 10 j cap. So by using this, I am just drawn the diagram. So this is along the positive x-axis. This is along negative y-axis. Okay. This is what their resultant. Their resultant can be given by magnitude. After doing the magnitude, I got 10 root 2. So the resultant of these two velocities is equals to how much? 10 root 2 meter per second. And it is making an angle theta is equals to 45 degrees from the positive x-axis. How to find the direction? By using tan theta. That's it. Okay. So if you draw the straight line, if this is 10, then this is also 10. Opposite side by adjacent side. Are you getting any doubts? Okay. Just pause the video and write the notes. Pause the video and write the notes. 3, 2, 1, go. Have a look. What is the example number 3 they are given? A police van moving on a highway with a speed of 30 km per hour. A police van moving on a highway with a speed 13 km per hour fires a bullet at a thief's car which is speeding away from the same direction with a speed of 190 km per hour. Okay. So if the muzzle speed of a bullet is 150 meter per second, find the speed of the bullet with respect to thief's car. Okay. So what they are given, have a look. So on a highway, a police van is moving. A police van is moving with a speed. How much speed? 30 kilometers per hour. Velocity of policeman is equals to 30 kilometer per hour. So on the same highway, in a same direction, on the same highway, in the same direction, a thief's car is moving. Thief's car is moving. So have a look. So this is the velocity of thief's car in a same direction. In a same direction. How much more? 190 kilometer per hour. So what happened? The policeman fired a bullet from police van. From police van, a policeman fired a bullet from this car. So that bullet is moves with a speed. That bullet is moves with a speed. So velocity of bullet is equals to how much? 150 meter per second. 150 meter per second. So what they are asking? Find the speed of the bullet with respect to thief's car. What they are asking? They are asking to find speed of the bullet with respect to thief's car is equals to how much? So this is the given information. Okay. So please pause the video and try the solution. So VBT is equals to what ma? VB minus VT. So VB and VT both are with respect to ground frame. That's it. So pause the video and try the solution. 3, 2, 1, go. Have a look. I'm going to find the solution. So velocity of bullet with respect to thief. Velocity of bullet with respect to thief's car is equal to velocity of bullet with respect to ground minus velocity of thief's car with respect to ground. So have a look. Here the police car is moving on the ground. So whatever the VP is there, so that VP is with respect to ground. Velocity of police car with respect to ground. How much ma? 30 kilometer per hour. 30 kilometer per hour. Okay, sir. Here bullet. So the velocity of the bullet is equals to 150 meter per second, and it is fired from police van. It is not moving on the surface of the ground. It is fired from policeman's van. So whatever the velocity of bullet is there, that is velocity of the bullet with respect to policeman's van. So that is equals to how much? 150 meter per second. So next they are given thief's car. So velocity of thief's car is equals to how much? So it is moving on the surface of the ground. So velocity of thief's car with respect to ground is equals to 190 kilometer per hour. Okay. So this is in kilometer per hours. This is also in kilometer per hours, but it is in meter per seconds. So just I am converting this 150 meter per second into kilometer per hour. For that we have to multiply with 18 divided by 5. kilometer per hour. So this is the velocity of bullet with respect to policeman's car. So what we have to find? We have to find velocity of bullet with respect to thief's car. That is equals to velocity of bullet with respect to ground minus velocity of thief's car with respect to ground. We have velocity of thief's car with respect to ground, but we are not having the velocity of bullet with respect to ground. So we have velocity of bullet with respect to policeman we have. So what we have to find velocity of bullet with respect to ground. So further, have a look. This is the velocity of police car and this is the velocity of the bullet. So velocity of bullet, velocity of bullet with respect to policeman, with respect to policeman's car. So that is equals to, we can write velocity of bullet minus velocity of policeman's car. Are you getting? VBP is equals to VB minus VP with respect to what? Ground. Ground. Now what we need? Velocity of bullet with respect to ground. From this we can write velocity of bullet with respect to ground is equals to VBP. If minus term comes to this side, it becomes plus term VPG. So VBP is equals to how much? Have a look. 5 ones are 5, 530 is a 30 into 80, 540 kilometer per hour. So that is equals to 540 plus VPG. VPG is equals to how much more? VPG is equals to 30 kilometer per hour. So this is also in kilometer per hour. So 540 plus 30, 570 kilometer per hour. So just substitute of VBG and VTG here. So we got the answer. Velocity of bullet with respect to thief's car, VBT is equals to VBG. How much? VBG is equals to 570 minus VTG is equals to how much? 190. Okay. So 0 minus 0, 0. 17 minus 9, 8. 4 minus 1, 380 kilometer per hour. So this is the velocity of bullet with respect to thief's car. Are you getting any doubts? So just to practice once, you can understand. Okay, right. Shall we do that problem? Okay, right. So what they are given? Solution. Have a look. Three boys A, B, C are situated at the vertices of an equilateral triangle of side D at time t is equals to 0. Okay, so there is an equilateral triangle. Okay, so the sides of an equilateral triangle is what? D, D, and D. These are the sides of an equilateral triangle. So at the vertices of this equilateral triangle, there is a boy A, boy B, boy C are situated at a time t is equals to 0. At a time t is equals to 0. As we know that in case of equilateral triangle, each angle is equals to how much more? 60 degrees, 60 degrees, 60 degrees. So that is the angle made by each sides. Okay. So what they are asking? Each of the boy moves with a constant speed v. Each boy is moves with a constant speed v. A is always moves towards B. So the boy A is always moves towards B, and B moves towards C. B is always moves towards C, and C always towards A, and C always moves towards A. So what they are asking? When and where they meet each other. When and where they meet each other. So this is the question. So they have taken one equilateral triangle. At the vertices of equilateral triangle, there is a boy A, boy B, boy C at a time t is equals to 0. Okay. The sides of an equilateral triangle is equals to how much? D, D, D. Okay. So after some time, a boy A moves towards a boy B with a speed V. So this boy B moves towards boy C with V. C moves towards A with a speed B. So what they are asking? When and where they meet each other. When and where they meet each other. They are asking the time and where they meet each other. At what point they meet each other. They are asking these two questions. Okay. Right. Just pause the video and try the solution. Pause the video and try the solution. 3, 2, 1, go. I'm going to solve the solution. Have a look. This is a given triangle is an equilateral triangle. It is a symmetrical triangle. So D, 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 60, 60, 60. It's a symmetrical triangle. Therefore, by the symmetry of triangle, the path of A comma B and C are as shown in the figure. As shown in the figure. That means so after some time they are moving like this now. A to B, B to C, C to A. The path of the person A is like this. Okay, so the path of the person A is like this. Okay, so the path of person B is like this. Okay, and the path of person C is like this, and they will meet at a centroid of the triangle. They meet at a centroid of the triangle. Centroid of the triangle. So where they meet in case of symmetrical triangle or in case of symmetrical shapes, they are meet at a, if it is triangle, they meet at its centroid. Okay. So when they are meet, they are asking when they are meet. So time t is equals to how much we have to find. Further, have a look. This is the direction of velocity of person B. So this is the direction of velocity of person B, and this is the direction of velocity of person A. Person B, person A. Have a look. This is a V is making an angle 60 degrees with this side. This velocity vector is making an angle 60 degrees with this side. Now this velocity vector along theta side, along theta side, along 60 degree side, you will get how much now? V cos 60. V cos 60. That means whatever the velocity component of this boy B towards, towards, towards direction of A, towards direction of person A is given by how much? V cos theta. That means V cos 60 degrees. That means the velocity component of this boy B towards this direction is how much? V cos 60. And have a look from this point. From this point, the person A is also moving with velocity V towards B. So this is the direction of velocity component of B person, and this is the velocity of A person. Now they meet each other. They meet each other. So now what is the distance traveled by the B and A person? So the distance is equals to how much more distance traveled by these two persons when they are meet is equals to D. We have to find the time. So time t is equals to, we can write distance by velocity. What is the distance? Distance is nothing but d. What is the velocity? The velocity of by b, v cos 60. The velocity of by a, v. So that is equals to d by cos 60. The value of cos 60 is 1 by 2 plus v. So time t is equals to distance by 2 into v, 2v, 2v plus v, 3v divided by 2. So that is equals to what, ma? 2d by 3v. 2d by 3v is the time taken by the persons to meet each other at the centroid. At the centroid. Are you getting any doubt? Just pause the video and write the solutions. And please practice. Please practice. Then you can understand what is happening there, what is happening here. Okay? Right. So pause the video and write the solutions. 3, 2, 1, go. Right. Have a look and just bring the example number 5 and example number 6. And these are the last examples of today's lecture. Okay. Right. Are you happy? Okay. So example number 5. This is a JEE Mains 2019 year question. So what they are given, have a look. A person walks up a stationary escalator in a time t1. So solution, have a look. There is an escalator. Okay. So let us consider the length of the escalator, let us say L, and the person is walks up on stationary escalator. So initially the velocity of this escalator is how much? 0, and this person is walks up on a stationary escalator. So in a time t1, so the time taken by this person to reach from this end to this end on the stationary escalator is equals to how much? t1. So the velocity of person P, the velocity of person P with respect to escalator, is equals to how much, ma? Velocity is nothing but what? Distance by time. That's it. This is the first case they are given. Velocity of person with respect to stationary escalator is equals to L by T1. Next, if he remains stationary on the elevator, then it can take him up in the time t2. Now what happened? This is a case 1. In a case 2, now the person is at a stationary condition. That means his velocity is 0. So velocity of person is equals to 0. Now the elevator is moving. Now the escalator or elevator is moving with respect to ground, velocity of escalator with respect to ground. Again, the time taken by this escalator to bring this person from ground to this point is equals to how much? T2 is equals to how much more? T2. So length of the escalator is how much? L. Again, L, its length is not changes. Now the velocity of escalator with respect to ground is equals to how much? Distance by time. So this is the second case they are given. So what they are asking, how much time would it take him to walk up the moving escalator? So in a third case, the escalator is also moving. The escalator has certain velocity. Also, the person is moving. This person is also moving. Okay. Now the escalator is moving. The person is also moving on the escalator. Now what they are asking? What is the time taken by this person? Okay. So what they are asking? What would be the time taken by this person to walk up the moving escalator? So escalator moving. The person is also moving. Now what is the time taken by this person to reach length L? They are asking this. Okay. Right. Did you understood? Okay. Pause the video and try the solution. Pause the video and try the solution. 3, 2, 1, go. I'm going to solve the solution. Have a look. Here we have velocity of person with respect to escalator is how much? L by T1. Here we have velocity of escalator with respect to ground. How much? L by T2. Now both are moving. Both means escalator and person. Both are moving. And what we have to find? The time taken by this person to reach this point to distance L is equal to how much? Case both elevator or escalator and person both are in motion. Both are in motion with respect to ground. So with respect to ground, now both are in motion. Now to find the time t. Now to find the time t. So what would be the time taken him to walk up the moving escalator? So if you wanted to find the time t, what you have to find, you have to find the velocity of this person with respect to ground. Velocity of person with respect to ground. So that is equals to velocity of person with respect to escalator plus velocity of escalator with respect to ground. That is your answer. Are you getting? In a first case, only the person is moving on the escalator. That means his velocity with respect to escalator is equals to L by T1. In a second case, he is at a rest position and the elevator is in motion. Then the velocity of elevator with respect to ground, because he is at a rest position. Now the velocity of escalator with respect to ground is equals to L by T2. Now in a third case, escalator as well as escalator and person both are moving. What they are asking, what is the time taken by this person to cover this distance? They are asking. Now here we have velocity of person with respect to escalator, velocity of escalator with respect to ground. In this case, the person as well as escalator both are in motion with respect to ground. Now if you want to get time taken by this person to cover this distance, gives velocity of person with respect to ground. So we know the formula, Vpg is equals to Vpe plus Veg. In a concept only we are discussing now how to find the velocity of particle with respect to ground. So velocity of particle with respect to ground is equals to velocity of particle with respect to S dash frame plus velocity of the S dash frame with respect to S frame. That means ground. S means what? There, ground. Okay, Pg. Velocity means distance by time. Let us say time taken by the person to reach this point to this point. Let us say T. So distance is same L, that is equals to Vpe is equals to L by T1 plus Veg. Veg is equals to L by T2. So L get cancelled out and we got 1 by T is equals to 1 by T1 plus 1 by T2. So from this T2 plus T1, 1 by T is equals to T2 plus T1 divided by T1 T2. Cross multiplication T2 plus T1 divided by T1 T2. If you wanted to find the T is given by T1 T2 divided by T1 plus T2. So this is the time taken by the person to cover distance L when he is moving on a moving escalator. Okay. Right. Did you understood? Okay. Practice. You will get. So solution question number 6. What they are given? Ship capital A is 10 kilometers due west of ship B. Ship A is heading directly north at a speed of 30 kilometers per hour, while ship B is heading in a direction 30 degrees west of north at a speed 20 kilometers per hour. Their closest distance of approach is. So what they are asking, sir. Okay. So let's draw the diagram. We will get an idea. Ship A is 10 kilometers due west of ship B. So have a look. I'm just drawing the diagram. Right. So what is this? This is east. This is west direction. This is north direction, and this is south direction. Ship A is 10 kilometers due west of ship B. So let us consider here is a ship B. From ship B at 10 kilometers, at 10 kilometers distance, there is a ship A. There is a ship A due west direction. Ship A is heading directly north at a speed of 30 kilometers per hour. So this ship A is directly moving towards the north direction with the speed VA is equals to how much one? 30 kilometers per hour. Okay, sir. While ship B is heading in a direction 60 degrees west of north. 60 degrees west of north. That means have a look. This is west and this is north. So west of north means so in this direction the ship B is moving. So by making an angle how much more? 60 degrees with west of north. With west of north. With a speed 20 kilometers per hour. So velocity of ship B is equals to how much more? 20 kilometers per hour. Right. Their closest distance of approach is, so it is moving like this, it is moving like this. So what is the closest distance between ship A and ship B? We have to find. Okay, right. So I'm going to solve the solution. This is the south direction, right hand. So velocity of an object A, ship A is equals to how much more? 30 kilometers in north direction. In north direction, what is unit vector? J cap. Okay. So what is the velocity of ship B? Ship B is moving 60 degrees towards west of north. Towards west of north. That means it is moving like this by making an angle 60 degrees with north. Now along north direction, its a unit vector is j cap. So the velocity vector along this side is equals to how much more? 20 cos 60 degrees into j cap. That is equals to 20 into cos 60. 1 by 2 j cap. 2 ones are 2 tens are. That is equals to how much? 10 j cap. In this direction, the velocity of B is equals to how much? 10 j cap. So this is along theta side and perpendicular to this direction, perpendicular to this. So you will get VB sine 60 degrees. VB sine 60 degrees. Along this direction, this is what? Negative x direction. Along negative x direction, what is the unit vector? Minus I cap. Minus I cap. So VB means 20 into sine 60 root 3 by 2. So 2 ones are 2 tens are. That is equals to minus 10 root 3 I cap. Minus 10 root 3 I cap. Now what is the net velocity of B? Net velocity of B is equals to 10 j cap minus 10 root 3 I cap. 10 root 3 I cap. So we can write VB is equals to minus 10 root 3 I cap plus 10 j cap. Okay. Now what we have to find? We have to find the closest distance of approach. Closest distance of approach. Further, I am finding relative velocity of B with respect to A. Velocity of B with respect to A. It gives what more? Velocity of B minus velocity of A with respect to ground, whatever it is. Okay. So what is velocity of B? Minus 10 root 3 I cap plus 10 j cap minus VA is equals to how much more? 30 j cap. So that is equals to minus 10 root 3 I cap minus 30 j cap plus 10 j cap plus 10 minus 30. You will get minus 20 j cap. So this is what relative velocity of B with respect to A. Relative velocity of B with respect to A. So have a look. So from this condition we got, so we know that the distance between ship A and ship B is how much? This is a ship B and this is a ship A. So the distance between them is how much ma? 10 kilometers. So 10 kilometers is the distance between ship A and ship B. Right. So from this condition, the relative velocity of the object B with respect to A, the velocity of an object B with respect to A along minus I cap direction, along minus I cap direction is how much? 10 root 3. So that means in this direction, the relative velocity of B with respect to A is in this direction. How much ma? In this direction, along negative I cap direction. Along negative I cap direction is how much? 10 root 3 is how much ma? 10 root 3. And along negative j cap direction, along negative j cap direction, downward direction is how much? Is how much? 20 j cap. 20 j cap minus 20 j cap. This is what? Minus 10 I cap. So whatever it is, minus 10 I cap minus 20 j cap represents the direction of the velocity. Now I wanted to find the net resultant velocity of this B with respect to A. Net resultant velocity of B with respect to A. So if you wanted to find the net resultant velocity, what you have to do? Just we have to make root of coefficient of I cap square 10 root 3 whole square plus coefficient of j cap square, that is 20 square. So 10 times are 100. Root 3 whole square means 3. 3 into 100, 300 plus 20 into 20, you will get 400. So we got root over 700. So root over 700 means what ma? Are you able to see the board? Okay. Right. So root over 700 value is how much? 10 root 7. We can write 10 root 7. Are you getting? Okay. So this is what? Magnitude of velocity of B with respect to A. How much? 10 root 7. So now this value, now this resultant of velocity of B with respect to A is equals to how much? 10 root 7. We got how much more? 10 root 7. This is the resultant velocity of B with respect to A. Relative velocity of B with respect to A. Resultant. How much? 10 root 7. Now I am considering the angle made by this B with resultant vector is theta. Let us say an angle theta. Now what we have to find? We have to find their closest distance of approach. Their closest distance of approach. If you wanted to find the closest distance of approach, so just you have draw a straight line towards this resultant vector and it gives what? The closest distance of approach of A and B. A and B. That's it. So how to find this closest distance? For that, have a look. This is an angle theta. So this is opposite side. This is what? Adjacent side. So from this triangle, we can write sine theta. So big triangle, I am taking big triangle, this triangle. So sine theta. Sine theta is equals to, we can write opposite side by hypotenuse. That is 10 root 7. So opposite side by hypotenuse. So 10, 2 is 20. So we got sine theta is equals to how much more? 2 by root 7. From big triangle. This is from big triangle. So have a look from this small triangle, BA, this one. Okay. So this is small triangle. We can write again sine theta is equals to, again sine theta is equals to opposite side. What is the opposite side? X. At this time, what is the hypotenuse? 10 becomes hypotenuse. Have a look. So in this triangle, this is what? Perpendicular line. Okay. This is 90 degrees. So whatever the side is opposite to 90 degrees, that is hypotenuse. Sine theta is equals to opposite side by hypotenuse. So just equate these two equations. Okay, just equate these two equations. You will get x by 10 is equals to 2 by root 7. 2 by root 7. From this you will get x is equals to 20 divided by root 7 meters. So this is the closest approach of A and B. A and B. Are you getting? Right. So once again, go backward and listen the solution once, you will get clarity. Okay. Right. So pause the video and write the solutions. Pause the video and write the solutions. 3, 2, 1, go. Right. So this is the end of the today's lecture. I hope that you are understood the concept. Once if you understood the concept, then you can easily do the problems. Okay. Right. So we will meet on a next lecture, that is a man-brain problems. Man-brain problems. Okay. So it's time to say signing off. Okay. Right. So this is Rakesh signing off. Stay tuned. Jai Hind.